Today's video is about dynamic NFS provisioning. Okay, so I did a video on dynamic NFS provisioning a couple of years ago. So if I search in YouTube, if I search for just me dynamic NFS, and you will see this Kube 23 video, dynamically provision NFS persistent volume in Kubernetes. This was done 2 years ago, and if you try to follow the steps in this video as of now, in a Kubernetes cluster that's 1.20 or later, you would have some problems running it. Thanks to a couple of viewers who pointed out that issue, so I'm going to try that. I'm going to show you exactly what the issue is and what to use going forward. Okay, so I still recommend you to watch this video because I've gone over some basics. So in order to get some fundamentals right, I would suggest you to watch this video because I'm not going to repeat everything what I've said in this video because that's still relevant. The only thing that's going to be changed is the repository that I'm going to use. So the original repository that I used when I did this video has been archived. No more development going into that repository. So I want to use a different repository. But before going that way, I wanted to show you what error you exactly get if you follow the steps in this video. All right, so I've got my Kubernetes cluster ready. If I do k-get nodes, one master, two worker, it's my usual Vagrant environment running on VirtualBox. If I do k-get pods -a, all usual system pods running in the kube system namespace. Okay, so I'm going to go into my play directory and then git clone my Kubernetes repository. Already exist. Okay, so I've already git cloned my Kubernetes repository. So once you've done that, go into Kubernetes, YAMLs, nfs-provisioner. Before deploying all these things, I'm going to provision an NFS server. I need an NFS server running somewhere, so I'm going to use my host machine to run the NFS server. So let me come back to this to these manifests later. First, I need to set up an NFS server, an external NFS server that I'm going to use for my Kubernetes cluster as a storage provisioner. So that's the idea of this video, right? So you've got an NFS server external somewhere, and you're going to deploy a dynamic NFS provisioning tool in your Kubernetes cluster so that it can connect to the external external NFS server and create volumes on the server. Okay, so I'm on Arch Linux, so I need to install the NFS utils package, which I've already done. Okay, so I'm not going to install it again. And the next thing is, depending on which distribution you use, I'm not going to go into details of how you're going to set up an NFS server, but in Arch Linux, it's usually NFS utils package. Both the NFS client and NFS server tools comes with this single package, NFS utils. So once you've done that, and I'm also going to make a directory called srv nfs kube data. That's where I'm going to store all the persistent volumes for my Kubernetes cluster. And I also need to change the ownership to nobody. And if you're on other distributions like Ubuntu, I think it's called NFS nobody or something. Okay, so we've created the directory that we want to share. We've installed the NFS package, and now I need to export the NFS share. So for that, I'm going to edit the etc exports file. And the directory that I'm sharing is srv nfs kube data, and I'm sharing it to the world. And I'm going to add a few options here: read, write, sync, no subtree check, no root squash, no all squash, and finally insecure. Okay, save the file, and I'm going to enable and start the NFS server. Okay, and I'm also going to do sudo export fs -rav to re-export so once you update etc exports file, you just need to run this command so that it exports everything you've described in that etc exports file. And you can also run this command sudo show mount -e localhost. It tells you what directories are being exported through the NFS. I've got my NFS server set up, so now what I need to check is I need to log into my Kubernetes nodes, and I need to make sure that my Kubernetes nodes can mount this NFS volume. So if it's not going to be, if you can't mount this NFS volume from your Kubernetes nodes, then it's not going to work. The nfs-client-provisioner is not going to work. So this is a fundamental check that you need to do. All right, so I'm going to log into one of my worker node, root at kworker2, password is kubeadmin. All right, so because this is an Ubuntu machine, I need to install the NFS common package in order to mount an NFS volume. So I'm going to install apt install nfs common. But let me show you, if you don't install nfs common, how did I find about this nfs common package? So that's a default, a blank, a vanilla Ubuntu machine, Ubuntu 20.04. And if I try to mount an nfs volume from my host machine, so I'm running nfs server on my host machine, which is 192.168.0.15. Let me try to mount it. Mount minus type is nfs 192.168.0.15, and the directory is srv nfs cube data, and I'm going to mount it under /mnt, and that's the error you get usually, mount.nfs helper program. So for this you need to install nfs common package. Because I'm on an Ubuntu machine, I need nfs common. If you're on Arch Linux, you need nfs utils package. Right, package is installed. Now if I try and run the mount command again, I can mount it. So that validates my mount. So mount is actually working. I can indeed mount the nfs volume from my host machine on the Kubernetes worker node. And if I do mount and grep for kube data, yeah, so that's the mount point. Going to unmount it and exit out of it, going to kube worker 1, kubeadmin is the password. I'm going to do the same thing here as well. App install -y nfs common. Alright, package installed. Mount -t nfs 192.168.0.15 srv nfs cube data /mnt. Cool, so that's working. You mount /mnt exit. Okay, so I'm still following the same steps that I originally did in this video. So now we've got our nfs server. We verified that from Kubernetes worker nodes we can mount our nfs volumes. Alright, so now in my Kubernetes repository under YAMLs directory and under nfs-provisioner directory, I have these files. The first thing is we need to create the RBAC manifest, and if I quickly show what's inside the RBAC YAML, so we're creating a service account called nfs-client-provisioner and a cluster role which has permission to get, list, watch, create, delete persistent volumes, and get, list, watch, update persistent volume claims, storage class, and events. And there's a cluster role binding, which is actually a way to bind this cluster role to this service account. And finally, we also have a role and role binding. That's it, nothing much. So I'm gonna deploy this RBAC.yaml. Cool, that's done. Service account, cluster role binding, role, and role binding. The next thing I'm going to do is deploy the class.yaml. Right, so if I show you the class.yaml, so it's basically a simple class storage class definition, right? So metadata, the name of the storage class is managed nfs storage, and the provisioner is example.com/nfs. And it has to match the provisioner name that you're going to use in the deployment.yaml. So I'll come to the deployment.yaml in a minute, but here the name is what it matters, managed nfs storage. Whenever you're creating a persistent volume claim, if you want to use this storage class, you need to specify managed nfs storage as the storage class in your persistent volume claim. But if you don't want to specify the storage class for every single persistent volume claim that you're going to create, then you can make the storage class a default storage class. So how do you do that? You just need to add an annotation to the storage class so that whenever you're creating a persistent volume claim, you don't have to specify the storage class. Since you made the storage class the default storage class, all the persistent volume claim is going to use the storage class. So if you prefer that, go for default-storage class.yaml. And if I show default-storage class.yaml, it's exactly the same thing except for the fact that we've got the annotation here. So let me create this kubectl create -f default storage class.yaml. So that's created. Finally, we are going to actually deploy the nfs-client-provisioner deployment. So if I show you the deployment.yaml, alright, so we need to make a change to this deployment.yaml, the nfs server IP address and the path. Path is actually the same srv nfs cube data, but we just need to change the nfs server IP, okay? Let's change that. Deployment.yaml, change the server IP to 192.168.0.15, and again here 192.168.0.15. Save that, and I'm going to create this deployment.yaml, Okay, that's done. If I do k get pods, nfs client provisioner is getting created. So once this is done, we are going to try and create a test persistent volume claim and see if it's going to create a persistent volume. Right, our nfs client provisioner is running fine, and if I go one directory above, and under the YAMLs directory I have a sample manifest called for pvc nfs.yaml. So if I show that for pvc nfs.yaml, it's a very simple persistent volume claim. The name is pvc-nfs-pv1. The storage class name is manual, so I need to edit this. I either need to change this to managed nfs storage, or I don't have to specify the storage class name because I've got a default storage class. So if I do kubectl get storage class, you can see the managed nfs storage. That storage class is the default storage class, so I don't have to specify the storage class. So before deploying this, I'm going to edit pvc-nfs.yaml and delete the storage class. If you didn't do the default storage class, you have to specify managed nfs storage. So that's the storage class that we deployed. 500 meg read write mini. Right, I'm going to deploy this. Create -f for-pvc-nfs.yaml. Right, our persistent volume claim is created. Okay, so I'm expecting a persistent volume to be created. K get pv, pvc. Alright, so persistent volume claim is still pending. I don't know why, because so that's the problem. So if you're following Cube23 video, you will get stuck at this point. Right, what's happening here? K get pods. Let's take a look at the logs for the nfs client provisioner. K logs nfs client provisioner. Okay, so that's the error you usually see. Class managed nfs storage, unexpected error getting claim reference. Self link was empty, can't make reference. I don't know what this is about, but I've seen a Github issue regarding this, and they are working on a fix, but I'm not sure when it's going to be merged into this nfs client provisioner. But going forward, I would advise you guys to use a different repository. Basically, it's a fork of nfs client provisioner, but the more development is going on into the nfs-subdir-external-provisioner repo, which I'm going to show you in a minute. Alright, so you can see here clearly our PVC is not getting created, and I've shown you what the error you would see in the nfs client provisioner part. Let's go ahead and delete all these. Delete -f for-nfs pvc nfs YAML. We've deleted our persistent volume claim. I'm going to go into nfs provisioner. Okay, delete -f rback.yaml, deployment.yaml, and default storage class.yaml. So basically I've deleted everything, and if I do k get pods, nfs client provisioner is getting terminated. Alright, so the original repository that I used in this video, Cube23, is if I search in GitHub for nfs client provisioner, it's this one here, nfs client provisioner GitHub. That's the original repository that I use, and if you can see here, this repository has been archived. It's now read only. Okay, and you also get a link here. This has been moved to nfs-subdir-external-provisioner, which is what we are going to be using, and you can either click here, or if you search in GitHub for nfs-subdir-provisioner, that's the one, Kubernetes 6 nfs-subdir-external-provisioner. So this is what I'm going to be using going forward. So, and also for this video I'm going to stick to a specific version, 4.0.2, because in the future, if you're watching this video and if you're following my steps, remember, if you're using the master branch, you know, master branch tends to change quite often, so the things that I'm showing you today might not work in the future if you're using the master branch. So make sure to use 4.0.2, or if you're using the master branch, let me know if you've got any issues. I'll be able to help. Okay, so 4.0.2, and there are a couple of ways to deploy nfs-subdir-external-provisioner. One is through helm, and the other one is through the normal manifest file. So I'm going to go through both these options, both these methods. Let's go through the without helm way. Okay, so for that, all we need to do is go into this deploy directory, and we've got a bunch of manifest files. So one is the RBAC, the other one is the deployment, the other one is the class. It's the same as the one that I've shown you in my usual nfs provisioner. RBAC, deployment.yaml, class.yaml. I think it's exactly the same. It's just a fork of the nfs client provisioner project. But the one thing that you will notice is in the deployment.yaml, if you look in the image, it's k it is staging sig storage nfs-subdir-provisioner 4.0.1, whereas here the image is different, external storage nfs client provisioner. So that's the difference. Alright, so The first thing is I'm going to deploy the rback.yaml. So let's copy that. It's exactly the same. Copy, and I'm going to go to my play directory, make a directory temp cd to temp, and I'm going to create rback.yaml and paste that, save, create -f rback.yaml. Okay, it's exactly the same. Service account, cluster role binding, role, and role binding. Cool. And the next thing is we've deployed rback, so now we're going to deploy the storage class. So go into the storage class. Again, it's exactly the same, managed NFS storage. And I'll come to this option in a bit. Archive on delete is false. Let's play with that once we get it working. Okay, so copy. I'm going to create a file called class.yaml, paste that, save, and kubectl create -f class.yaml. Okay, so now if I do kubectl get storage class, you can see it's managed storage, managed NFS storage. So that's the storage class, but it's not the default storage class because it doesn't have the annotation. So if I show you the class, there is no annotation to make it the default storage class. So bear that in mind when we come to creating the persistent volume client. We need to specify the managed NFS storage as the storage class. Right, what else? So we've deployed rback class, and finally the deployment. Right, so if I copy this, and again we need to do some changes in this file, vi deployment.yaml, paste that, and the path, I'm going to change the path to srv nfs cube data, and the IP address of my NFS server is 192.168.0.15. Again, I need to do the same thing here, srv nfs cube data, and the NFS server IP is 192.168.0.15. Save, kubectl create -f deployment.yaml. Okay, get pods. Okay, so our NFS client provisioner is getting created. Let's wait for a few seconds. All right, so it's running. Kubectl logs NFS client provisioner, started the provisioner controller. So I think our NFS client provisioner is up and running. Right, let's go back here. And they've given us a sample NFS client. Either you can use this or you can use mine. Let's use the same example that I used for my previous testing, okay? cd to play, Kubernetes, YAMLs, and I'm going to deploy for pvc nfs.yaml. So if I edit for pvc nfs.yaml, so because I don't have the default storage class, I need to specify the storage class. So what's the storage class? It's this one. Right, pvc-nfs-pv1 kubectl create -f pvc nfs.yaml persistent volume client created. Right, kubectl get pv, pvc. There we go. So that's our persistent volume client. The status is bound, so it has automatically created a persistent volume, and the status is bound. Clearly this one is working. So going forward, don't use NFS client provisioner because that's archived, and use nfs-subdir-external-provisioner. So we made sure that it's actually working fine. Now let's go ahead and do some testing. Let's delete that kubectl delete -f. I've deleted my persistent volume client. Get pv, pvc. Actually, I wanted to show you something. So the storage class that we created, kubectl get storage class. So we basically deployed the storage class with this option, right? Archive on delete is false. Yeah, maybe I can show it here. Class.yaml. So archive on delete is false. So that's the option. What does that option mean? So archive on delete is set to, if that is set to false, when you delete your persistent volume client, it's going to delete the persistent volume. It's also going to delete the volume on the remote NFS server. But if you set this archive on delete option to true, then when you delete your persistent volume claim, it will delete the persistent volume, but it won't delete the volume on the remote NFS server. So that's what we're going to test now. Right, let me run the same command again. Kubectl create -f, right? Kubectl get pv, pvc. So we have a persistent volume claim and persistent volume. And if I do ls srv nfs cube data, you can see here, maybe without syntax highlighting. Right, so that's the name of the volume that we've created using the dynamic NFS provisioning on my NFS server under srv nfs cube data. Okay, so let me delete that. Kubectl delete I've deleted my persistent volume claim, and if I do kubectl get pv pvc, so both persistent volume claim and persistent volume has been deleted. And now if I do srv nfs kube data, my remote volume is also gone. So now what I'm going to do is let me go back to my previous directory, play temp, and here I've got the class.yaml. First I'm going to delete the one that I've created previously, class.yaml. Okay, so our managed NFS storage class has been deleted. I'm going to edit class.yaml and set this to true. Save that and create the storage class again. kubectl get storage class, and now you can see the archived on delete is set to true. And now if I do the same step again, play Kubernetes YAMLs, kubectl create -f -pvc. So I'm creating the persistent volume claim again. If I do kubectl get pv, pvc again, I've got my persistent volume created on my remote NFS server, which is my host machine, and I can do ls srv nfs kube data. So that's the remote volume there. And now let's say I deleted my persistent volume claim. Delete -f -pvc nfs.yaml. Alright, k get pv, pvc, persistent volume claim, and persistent volume is gone. Alright, so now if I take a look at srv nfs kube data, you can see here the volume is retained, and it's been renamed to archived. It has been prefixed with archive. So that's the difference when you use archive on delete is false. It might be handy in certain situations. Alright, so I'm going to go back to my temp directory where I've got all my YAMLs for nfs-subdir-external-provisioner, and I'm going to delete everything. I'm also going to delete rm-rs srv nfs data, kube data, archived, and in here I'm going to do kubectl delete -f, sorry, it's not default sc, it's class.yaml. Alright, so I've completely removed everything. If I do kubectl get pods, the nfs-client-provisioner is getting terminated. By the way, you can also deploy this nfs-client-provisioner in a separate namespace if you want. And if you want to do that on a separate namespace, you need to modify the rbag.yaml. Basically, you need to change in 4 places, I think. So replace with the namespace where provisioner is deployed. If you want to deploy this on a different namespace, change the namespace here. They've also added the comment, so you can change it here. Change the role, change the role binding. Okay, right, I'm going to go back to the nfs-subdir-provisioner. Now I'm going to show you how you can use helm to install. So that's going to be a little easier if you want. So I've got helm version 3.5.3 installed, and the first thing is we need to add the helm repository. I'm going to copy that. And before that, let me show you helm repo list. I don't have any helm repository. Let me add that repository and do a helm repo update. I do a helm repo list now, so I've got this helm repository added. The next command is we need to install the nfs-subdir-external-provisioner helm chart. So I'm going to copy that, but before pasting that, I need to modify something. So basically, I need to modify the nfs path to srv nfs kube data. So that's the nfs chart that I've exported from my nfs server machine, which is my host machine. NFS server is 192.168.0.15. That's it. I'm going to copy that, come back here, install. Right, and if I do helm list, nfs-subdir-external-provisioner status is deployed. Cool. And if I do kubectl get pods, our nfs-subdir-provisioner is running. kubectl get storage class. And the storage class now, the storage class name is nfs client. So if you're using the helm repository, they've changed the name of the storage class to nfs client. Whereas if you used the deploy directory and the storage class, they still have it as managed nfs storage. So that's something to bear in mind. Okay, that's done. Let me go back to my Kubernetes YAMLs, kubectl create -f nfs get pv, pvc. That's pending. Okay, so why is it pending? Persistent. I've created the persistent volume claim, and I was expecting the persistent volume to be created, and also srv nfs kube data. There is nothing there, and the status is pending. That's because I need to edit delete -f for let's delete the nfs Let's edit the persistent volume claim because the storage class name is wrong. It's not managed NFS storage, it's NFS client. Because if you do k get storage class, so that's the NFS client. Okay, and now let's run kubectl create -f persistent volume client. Right, k get pv comma pvc. Now you can see persistent volume is bound and the persistent volume is created, and I can do, that's the volume that got created on my NFS server. And if I do k delete, okay, everything is gone, and ls srv nfs cube data, and it's changed to archived default. That's because if I do storage class nfs client -o YAML, you can see archive on delete is true. So that's two things you need to note. The archive on delete option is set to true by default if you're using the helm method, and if you're using the normal method here, archive on delete is set to false, and the name of the storage class is set to managed NFS storage in the manifest, but if you go by helm installation, it's set to NFS client. Alright, so I think that's all I wanted to show you in this video. Give this a try and let me know if you've got any questions. I'll be happy to help. I'll see you all in my next video. Until then, keep learning and keep on learning. Bye-bye.